Good day, everyone. My name is Jordan Hopiolian, and today we are going to continue on our discussion on the principles of chemistry, part two of this lecture number two or lesson number two, part two. I believe we have stopped right here, the introduction to light. Okay, so just a quick review. No, a light is considered a stream of particles called photons whose energy is given or denoted in E is given by the equation E is equals to hv, or it is also equal to hc all over lambda, or the wavelength. So take note here that we have two um, parang equation. No, we have two equations right here. So this you can use either of one of this depending on what is the given variable that you have in your problem or sample problem. And just a quick notice also that light, it is a stream of particles. So there are the composition of a one light, there are a lot of particles that is present, and those particles are what we call the photons. So when you see a ray of light, you imagine that there are streams of particle, and that is called what we call photons. Now, the SI unit for light is in joules, or the SI units for energy. I mean, the SI unit for energy is joule, no, denoted in 1 kilogram meters squared over second squared. And take note also here that we are also using Planck's constant, where it is this number right here. And just a quick review also, or fun fact, no? You can actually, this is also actually in relation to, parang magkapatulad sila sa kang Einstein's equation wherein E is equals to mc squared, di ba? But kang Einstein is he is parang given yung parang gina-relate niya yon in terms of mass and speed of light, while in Planck's constant he is relating this via frequency or um, wavelength. So yeah, so let's to better understand this problem or this um, equation, we should have a sample problem. So let's start here. So very easy one. So yeah, you can try this. You can pause the video and yeah, see if you can get the correct answer. So we have this problem right here. So firstly, we have to first, right first what is our given. So take note here, this is in nanometers, and we should convert this into meters para makancel ang ating um, units. No, sorry guys if I'm speeding up our lessons. So because this is not the main point of my discussion right here, but I'm showing to you because it might be that you will use this in your physical chemistry. So yeah, we convert 589 nanometers into meters, and this is just very easy. No, we are given our lambda or our wavelength, and we should use this formula instead of the E is equals to HV, because that's you have, if you use that formula, if you use that formula, you can also use that. But it's parang gina-extend nyo yung kahaba ng solutions nyo kasi hanapin mo pa yung value ni frequency mo. But here, yeah, we are given the wavelength, so let's just use what is very um, easy. And this is also a technique when you are solving on your finals or your exams. We should have develop a speed of calculation. So yun, this is just a very basic, no, plug in nyo lang yung mga values natin. So if you are curious, where is this 2.998 times 10 to the power of 8, this is just the value of our speed of light. So take note here that in our discussion on lesson 1, no, we agreed, no, for the duration of my videos, we will use this constant. So in some other books, no, especially when you are using, um, I don't know, the latest edition of Principles of Chemistry by Ferrer. So throughout the duration of this topic, so we will use that. If you're using the latest version of Ferrer, Principles of Chemistry book, I think it was denoted in 3 point, uh, exactly 3, but no, it doesn't matter. It still arrive at the same solution. So cancel lang, i-plug in nyo lang yung sa calculator nyo, and you will get this value right here. And yeah, so let's try another problem. So this is a continuation of our first problem right here. So you have to calculate in kilojoules of 1 mole of such photon. So yun, for per 1 mole, no, we have this we have this value right here. That was our ito yung previous natin na nakuha natin, and we will use Avogadro's number. So you might be asking, why are we using Avogadro's number? Again, Avogadro's number is parang denote siya into atoms, into molecules, and this can be also related into energy or photons. No, per 1 mole of photon, we have 6.022 times 10 to the power of negative raised to the power of 23 photons of um, photons. Yan. So this is just a basic stoichiometrical problems. No, you can cancel, and you arrive at this value right here. Take note here, ha? Okay, it asks for 1 mole of such photon. It's 1 mole of such photons. That's why we convert mole to mole, no, mole to photon. I mean, yan. So again, this is another continuation to it. So you can pause the video if you like, and let's try this problem right here. So yeah, strategy again. So since we have this value right here, you start first with what is given and what is required, and before the solution. So I'd like to develop for my viewers right here. Please develop the habit of asking first what is the given, and and what is asking and what is required, so that you will have a very easy understanding on what you are solving right now. And also take note here, a tip of advice when you are solving, especially here, from what I did, this semester and taking this class. um I usually write all the time the units, so that if converting I'm not converting out of nowhere, no, so hindi ako malilito. So yun, always have the habit to do not forget to write the kuan units. Some students or some teachers, professors will not write anymore the units, because I think they are so good in solving, no, yeah, they na memorize na nila yung kuan yung pattern niya. So but us beginners, no, let's develop that habit right here. So here's the problem, very straightforward naman siya. So you just plug in the value, and use your common sense, as my professor once said, you know yeah. So let's go here. So the atomic spectra of gaseous elements. So yeah, it's usually in around 400 to 700 nanometers. No? So by that, the characteristics of gaseous elements like sodium have developed two strong lines in yellow regions of 589 to 589.6 nanometers seen in sodium vapor lamp. So what is just saying here that at specific spectra, atomic spectra, some gaseous elements or most gaseous elements produces light that parang kita ng kanilang characteristics, no. So right here we use sodium vapor lamp, no, at some point in the 500 region, or nag-green siya, and in the 600 nanometer region, ito yung kanilang color. So credits to the books. So the line spectra, the photon making up atomic spectra, have discrete wavelengths, implying that they can have or only have discrete energy because of that formula. So when we say discrete, so it must be specific. It cannot have 1.5 or 2.5, 3.5. It must be it must be specific or whole number. Dili siya in the Bisayan term, dili siya bungkig, di ba? So, and later on you will know, okay? Because this is you can apply this when electrons move from a low orbital to a higher orbital, no? The energy must be discrete and specific. So, if you start in the N1 orbital, if you move to the N2 orbital, no, the required amount of energy is a whole number. Dili siya bungkig. Inana siya. And because electronic energies are quantized and are limited into specific values. So, Jonathan Balmer. So for Niels Bohr, so if you happen to read um, the atomic theory of Niels Bohr, parang planetary model siya. But in that sense, the planetary model of Niels Bohr is not that quite accurate because it it discredit paano naman yung mga elements or parang yung mga tawag nito, mga atoms that is very large, like mga radioactive atoms, no, since the nucleus is very in those atoms, the nucleus is very large na masyado, and with that malakas ang electron, kanang parang magnetic pull ng inyong electron na di ba, opposite attract. So if you follow the Bohr's model, then therefore you will fail, or it will not specifically kanang describe those atoms. So that's why in this recording in this video, in the 21st century, we are now using the Schrodinger's parang quantum mechanical model. So yan, no, yan. And yun, this is his equation right here, the Rydberg's constant. So it's very cool. So note that in Niels Bohr, the zero is the point at which the protons and electrons are infinitely separated. So if you have a electron, no, moving out of the atom, no, wala siya sa atom nimo, no, in the energy there is zero already. The ground state, however, is the closest. Ang electron mo is napakalapit na sa nucleus mo. Ground state na siya, lower energy state na siya. And also, please be critical on saying lower energy. What type of energy is it's lowering? So when we say lower energy, it's actually mentioning na kapag malapit ng electron mo sa inyong imuhang nucleus, no, maliit ang kanyang potential energy, okay? Pero malakas ang kanyang kinetic energy because it will produce a lot of kinetic energy to counteract the pulling force of your atom or your nucleus para di siya mag-collide sa imuhang nucleus. So, please also take note na please review your Gen Physics 1, yung in different kinds of energy, the potential and the kinetic energy, because you will be confused if you do not know the distinguish between the two states. No? If malayo ang electron mo sa nucleus, then it is higher in potential energy, not kinetic. Okay? So, with that being said, no, we can actually apply the Bohr's equation using ito na equation na ito na yung sinasabi ko that the energy of your electron must be specific or because quantized. So dapat dili siya bungkig. Okay? Because of this equation right here. If you are moving an electron to a higher energy orbital, no, it cannot have a 1.5 energy or 2.5 energy. It must be specific because you must quantize them. Okay? So to better wait, let's go back here. To better understand this, let's try this problem right here. So we calculate in nanometers the line of the Balmer series that results from a transition from N 4 to N2. So take note here guys, ang key nito is ano ba we have you have the starting electron from the n orbital of 4. So the fourth orbital going down to 2. So nag-release ka og energy. Always remember if you are in a uh, higher state, then nagbaba siya into lower state, meaning you are releasing energy. And those release of energy is in the form of light. But if you are in a lower state of energy, nag go up ka into higher state, you are absorbing energy. Okay? So meaning yan, nag-introduce ka og energy or source of energy to your electron that it made it move from a higher state. And a quick fun a quick FYI lang, when you are moving from a higher energy, no, it's actually temporary because later on, again, energy is neither energy is neither created nor destroyed, no, because of that, no, at some point that energy that your electron is absorbing, you will release it, no? It cannot be stored, no? So i-release lang na niya, then magbaba na po siya balik. So, yeah. So if you yeah, a very straightforward din ang equation mo. No, you just use the Rydberg's constant and your um, Planck's constant, and plug in everything, and you will have this one right here. But take note, we are you want to have your wavelength right here. So given this, we have now your frequency, and to compute for your wavelength, no, just use the previous equations to come up with this problem answer. So yan. Next is we have the quantum mechanical model. So here it is. So the quantum mechanical model. So yun nga, sabi ko no na when we go now to higher bigger atoms, no, ang Bohr's theory cannot suffice everything. But de Broglie says that okay, when photons um if light could show a behavior like a particle daw or photons as well as a wave, then perhaps an electron could behave like a wave also. So, he says, si de Broglie, nag-isip siya na-observe niya, nag-think siya ba, na, wait, if light can become a wave or like acts like a wave, but also acts like a particle, no? Can electron do it as well? Hinana niya yung pagthinking niya at that time. And in that sense, when he inquired those thinking, it evolved now into what we know as the quantum mechanics, no? And yun, the kinetic and it stays here. Sabi ko nga, no, be specific on what type of energy you are indicating. No, kinetic energy of an electron is inversely related to the volume of the region of space that is confined. So ito lang yung sinasabi ko kanina, basically, no? Yan, okay? So, no more, I will not explain this further. Na-explain ko na siya kanina. And yun. And because of the thinking of the Broglie, no, we come up now with Erwin Schrödinger's, no, now where he emphasizes that we cannot actually predict, the behavior of an electron because it acts like a particle and also a wave, and so in that sense we cannot specifically pinpoint on where does this electron are moving around the cloud, but in because of that, dili na to siya ma-predict, but however, we can know at where specific region of space in that cloud does the electron usually nag-a-appear. So, yun, ginamit niya yung maraming mathematical complex na math, no, na you will, I think we will discuss further on. So, if ma-discuss ko siya, yun. And that in the sense na develop now our quantum mechanical model of the atom. And fun fact, no, si Erwin Schrödinger is actually a student of Niels Bohr's. No, very ironic na that his student, yung estudyante niya ang nag-disprove ng kanyang theory of the planetary model. But it's actually flattering also to Niels Bohr's because in that sense, diba, he was a good teacher to Erwin Schrödinger. If I'm right, he was a good student of, he was a good teacher because he developed the thinking that sparks the innovative learning of his students. And, napakita niya na malaki talaga ang impact, or he really produced a bright mind at this generation. And because of that, it's also a quite privilege to Milford, despite it being parang nag na disprove ang kanyang model. Anyways, I will not discuss this further. No, very you can read naman this. So yun, let's go now here. So when we say orbital, this represents the region in space where 90% or higher probability of finding an electron. So, and in that sense, we will now discuss the quantum numbers or the quantum numbers here. So, Erwin Schrödinger's equation can be solved approximately for the atoms with two or more electrons, and the solutions results into orbitals which have an energy, a shape, and and orientation in space. We have N, L, and ML. So let's discuss this one by one. So when we say N, this is the principal quantum number like N, 1, 2, 3, 4, 5, so on and so forth. And L is actually the derivation of your N, no, wherein it can be solved using N, your any number of principal quantum number, you subtract it by 1. Okay? Or you can use this one right here, SPDF. Ito siya. And each letter has a corresponding number now. 0, 1, 2, 3. So, ano ba ang L? So, ang L actually guys is just, kanang the number or your, tawag na to, it's, imagine this like, you are in a building, no? There are a lot of rooms, no? And each room has doors, no? Yung mga rooms na yun you have a building, and inside that building, no, there are a lot of rooms. That is your L, no? Your the sub yung parang sub room ng electron ba. And each of these have a corresponding shapes, no? You can research na. Mahirap i-drawing actually ngayon kinaka-laptop ako. So mahirap siya i-drawing, but you can search the one, you know, and that. And ML is just actually solved through the negative L to positive L. So and MS is just the spin. So to better understand this, let's go here. To better understand this, no, the Pauli exclusion principle, no, na discuss nito sa Gen Chem nyo. So, spins, no, there must not be two identical spins, like one must go up and one must go down. No? Spinning up and spinning down. They cannot have both electrons spinning both up or down. So let's try this. Let's try this to solve this. No. So sample problem. So ang goal nyo is which one is probable. No. This is our N. This is our P. Your L. So ano ba to na corresponding L natin? So if we have S, P, D, and F, no, 0 to siya, so 1. So this is a P orbital and 0. Is it possible in this combination? Take note that ML is just actually equal to the negative L and positive L natin. So if this is 1, so 0, we have negative 1 because we start here 0 and 1. So possible siya, check siya. And it must have a positive spin. So positive going up. So possible to siya, check to siya. So 2, this is the principal quantum number N. Yes. 0 is S. But here, possible din to. But here, you cannot have a zero spin. No, you must only have a negative or positive spin. No, so basically, ang ginaingon lang ani is, no, it's just describing the behavior of your electron in the submolecular level of your atoms. So I think you will have this better viewpoint in your kuan organic or physical chemistry, no? Ma-understand nyo lang ito, pero basically ito lang yung mga introductory level. So and also I will provide additional supplementary videos to better understand this problem, to this lesson I mean. So next is we'll discuss now the sub energy level. So this is now your energy level or your energy orbital in your atoms, no. And if you think you see this, no, very familiar siya kay mo ni imong electron configuration. So yan, this is just your orbitals here. And as you go higher, if your N is going higher, then you are increasing an energy level. So increasing energy level, potential energy level. So again, not kinetic but potential. And if you can see here, the 3P and the 4S and the 3D or the 4S specifically and 3D is very very close to each other, and this is very significant when you are writing an electron configuration of your um, transition metals, because if you have yung transition metals nyo, you have different you have two electron configuration because most of your transition metals is in the 3D orbital and malapit siya sa 4s orbital nyo. And if napakalapit ng kanilang orbital, no, the tendency is that your electron in your 4s will move higher into your 3D orbital. Okay? So may tendency na mag-jump ang imuhang electron ana. And that is one tricky way when you are writing your electron configuration when it comes to transition metals because of that sense, no. But for my professors, yung professor ko nang gi-ask ko, sabi ko na, so ano ba yung tama na, prof, ano ba yung tamang pagsulat ng electron configuration when we are encountering transition metals? And sabi niya na, well, it's given naman daw. So it's parang tawag nito, understood na when it comes to transition metals, no. And dapat specific. So but I'm assuming here that you know how to write the electron configuration, so it will not be a lengthy video. So if you do not know how to write an electron configuration, I will provide also the link or video lectures that I've used when I'm studying this. Na, that is very much napakagaling nila magturo. So I leave it to them because I'm not that good at teaching writing electron configuration. So anyways, so yan. That's one way, or this is the the continuation of the topic. And yun, you in your high school, no, siguro yung chemistry teachers nyo in your high school na pa-bring kayo ng ganitong electron configuration charts. But here in college, welcome to college, you are not allowed to bring that. So, paano ba yan siya? So, kung periodic table lang ang dalhin namin and yung list of cations and polyatomic ions namin, paano namin i-write yung electron configuration namin? Well, I will teach you the parang shortcut niyo. Okay? Remember nyo lang ito that in this block right here, in this period, ito na na group is the S group, including ang helium, including ang helium. And sa baba nito itong red something, red color is your P group, and your yeah, yung transition metals nyo, always remember when you are having a transition metals, these are in the D orbital and mag-start sila sa 3, okay? And yun, yung mga radioactives nyo ng mga atoms, no, yung mga radioactives nyo, this is in the F orbital. So mga F block to sila. So that's the way on your parang visualization nyo sa inyong electron configuration chart. So I'm not gonna focus here because napakataas na ng video nito and I wanted to make it short. So I'll attach a separate video or a supplementary video on the description box below on how to use this chart. If you are using how to use this using your periodic table. Gamit lang ito, no, without your electron configuration chart. So yan, fluorine example nito, ito yan. And ito Hans rule. So yeah, when we say substance that have unpaired electrons, take note of the word unpaired electrons. These are paramagnetic, and substance with all the electrons are paired, these are called diamagnetic. And to better understand this, let's have this chart right here. Now, when we say paramagnetic, no, it attracts to a magnetic field. Mag-attract siya sa magnetic field. Magnetic sila. If you could see here, no, half filled lang sila. Merong mga unpaired electrons. Okay? Here, when we say diamagnetic, no, filled or mostly filled ang kanyang electrons or your orbitals niya. No, paired electrons, and they repel magnetic fields, no, like your helium, your carbon, your copper, your silver, your gold. I'm right, is this gold? No, yun. If you can see here, yung mga example nito is not magnetic. And all materials that are diamagnetic, uh, all materials are diamagnetic, but in atoms with unpaired electrons, paramagnetism overcomes diamagnetism. So, take a very easy way to understand this, that all of our materials are diamagnetic, but when it comes to atoms daw, no, merong mga unpaired electrons nila, the paramagnetic or the paramagnetism of that characteristics overcome the diamagnetism of your substance. And yun, transition metals, they belong into the d orbital. So example right here is chromium, Cr. We have 24 electrons. And if you write this, ito yung noble gas notations. So um, in our quiz, no, I remember that we have a quiz in this part. And ito yung gisulat ko, 4s and 3d. Actually, tama din siya. And yung classmate ko, ganito ang pagkasulat niya, tama din siya. And so why is it? Because remember that your 4s, your s and b orbital here is very very close, that electron tends to jump into this electron right here, making 5 and making this 1. And sometimes, no, kung mag 5 ni siya, ang tendency din niya ang mga electrons nito mag-jump into pababa. May mga ganon, no? And that is very common when you have transition metals. So, either way, tama siya, pero I suggest you talk first with your professors on what do they prefer. No? Okay, so professors ko, in my back then in my case, my professor was sabi niya na it's okay, tama naman siya, tama naman yung dalawa. So, and he's not that strict, no, when it comes to writing the electron configuration. But anyways, you should check your the yung gusto ng professors niyo. And lastly, here is the highlight of your as a chemistry student or a bio student, your periodic tables. No, when we say periodic tables, this is now the list of your the list of your atoms. No, mga atoms known to Earth. So, ito yung mga atoms natin. So, this is very, anang kabalo na mo sa kung saan yun ng mga family, because naka-write na din siya dito. And just a quick a review, no? When you say ionization energy, okay, it increases up a period and across a group from left to right, increasing ang kanyang ionization energy. And also, this is same as true when you have electronegativity. The higher the period, o pataas sa period, no, from pataas sa period and across a group from left to right, ang inyong electronegativity niyan is higher, okay? But this is opposite when you have your group electron radius or kanang kadakuon sa inyuhang atoms, no? Across a period from right to left, decreasing ang kanyang atomic radius, and down a period increasing ang kanyang ulitin ko ha, across a group from from right to left, increasing ang kanyang atomic radius, but down a period, no, nag-increase po ang iyang atomic radius. And this is very true, because if you have a very electronegative atoms, no, the tendency is malakas yung electron pool niya, so mag-shrink ang kanyang atomic radius. While as compared to malaking atoms, I mean like malakas masyado yung electron negativity nila, or matagal silang ma-ionize, no, tendency is that they are not willing to share your electron or to give up an electron. So, yun, lumiliit sila, malakas yung pool ng kanyang nucleus nila. But if you have metals, no, specifically mga metals mo na mga mga atoms, no, they are very weak in ionization and electronegativity. So chances are they are willing to give up an electron rather than to share or take an electron. So yeah, very yan. That's really the highlight of the video. Very very fast siya, but this is very basic to you guys because this is an introductory level. No? I hope you learned something, and stay tuned to the next video. Thank you.